And we
it says
live.
it says we're live, but let me just check YouTube.
I can check LinkedIn.
Okay.
Nice.
Yes, we are live. Yes. How is it looking on LinkedIn?
It says that it hasn't started yet.
But I think it's on YouTube. So.
Yeah. Wait. Maybe it's only my computer that's a bit tired.
I think there's a delay on LinkedIn as well.
Yeah. Now it's live. Yeah. I had a push that QTypes live stream with CloudAMQP is live.
Nice.
Yeah, it works on my end as well on LinkedIn. Great. I think we have some people ready, right?
Yeah, we have 6 viewers. Nice. So where do you guys come from? Feel free to comment and tell us where you come from. I just realized our names are not showing.
Oh, really?
No, where did they go? They were here just like a minute ago.
Oh no.
Oh well.
Maybe the settings?
I don't know.
I think we have some comments.
Yeah, we have Atlanta, Georgia. Welcome. And we have Canada, Manitoba. Welcome.
Good morning.
Yeah, and it's afternoon in Sweden.
Yeah, it's afternoon here as well.
Yeah, in Nigeria.
Yeah.
Isn't it cool that we're doing this from 3 continents today?
Right.
Whoa.
We have
Netherlands and Finland and Switzerland. Oh, so much fun. And northwest of Spain. UK. Cool.
All around. Nice.
Sorry, it's 3 already.
I still think that I am the one closest to the Arctic Circle. Because I'm only 1 hour south of the Arctic Circle.
Oh, really?
Yeah. Didn't you know that?
I didn't. You live in the north of Sweden, right? Is it the
I do.
south?
I do.
Oh, okay. Yeah, makes sense.
Yeah, it's sort of me and Lovisa lives sort of at the same height in Sweden, but I'm a bit higher than she is. And I am the one the northernmost based person.
So you're not too far from Skellefteå?
It's a 2.5 hour drive to Skellefteå. So I guess what's a far drive? Over here, we're just so used to the distances. So, yeah. What time is it?
It's 3 already. So
wow. Yeah.
And we have about 26 people, so I think we can just get started.
Yeah, sure. Give me a second. So, hello everybody, and welcome to the CloudAMQP live stream. We are thrilled to see so many of you joining us. The topic of discussion today is RabbitMQ's different Q types. Together, we will break them down, talk about their unique powers and benefits, touch in on use cases, and share some tips for optimizing performance and maintaining high availability. If you have any questions, feel free to submit them in comments, and we will address them later. As I said, I am Sophie, based in the north of Sweden. And with me today, I have my colleagues, Nyior, Clement, and Dustin Turpin. Nyior has been a developer advocate with CloudAMQP for almost 3 years now. His tasks revolve around RabbitMQ, which typically involves exploring features, assisting customers, writing about RabbitMQ, and occasionally speaking about it. He is joining us from Abuja in Nigeria. Also with us, but from a different continent, is Dustin. He is based in St. Louis in the United States and has been with CloudAMQP for almost 2 years now. Dustin has recently switched teams from support to marketing, and we are super happy to have him. His daily tasks as a developer advocate revolve around RabbitMQ and LavinMQ, writing blogs, creating content, assisting customers with LavinMQ onboarding, and speaking about message brokers. All right, now that you know who you are listening to, let's not wait any longer to get this party started. Nyior, the stage is all yours.
Thank you, Fia, for the introduction. And to our audience, thank you so much for tuning in. We're truly honored that you took your time to come listen to us talk about Q types and RabbitMQ. I'm excited to be here, and I guess we can get started. Or Dustin, do you want to say a few things before we proceed?
Yes, I want to thank everybody as well. I'll be watching the comment section, watching for questions as we talk about various Q types. Feel free to comment in the platform that you're on, and we'll be making sure that we try to answer as many as possible. And yeah, looking forward to diving in.
Great. So yeah, I'm just going to jump right into it. We're going to talk about Q types and RabbitMQ, like I said, but towards the end of this talk, we have a bonus session for you on LavinMQ. If you don't know what LavinMQ is, that's okay. We're going to tell you all that you need to know about it. Now, before I talk about the different Q types, I'll give you a quick overview of what a queue is in RabbitMQ. So let's start from there. What is a queue in RabbitMQ? Now, a queue is simply the component that is responsible for persistent messages or just buffering messages in RabbitMQ. So how this usually works is you have a producer that sends messages to RabbitMQ. Then you have a queue. These messages would eventually land in a queue. Now, I am oversimplifying things at this point, but that's the most important thing you need to know. A message comes from a producer, it lands in a queue. Then you have a consumer that reads messages from this queue. Now, the inherent behavior of queues in RabbitMQ is they persist messages in the exact order they arrive. So consequently, consumers read these messages in that order as well, first in, first out. Now, this behavior is configurable in a way, and you'll see that you'll see why I said that a bit later. Queues in RabbitMQ. When RabbitMQ first launched in 2007, it had only one queue type, the classic queue, which was introduced in version. But then, of course, as time goes on, more queue types were added to RabbitMQ to just cater for the different use cases in which RabbitMQ was being used or could potentially be used. And yeah, so next, Quorum queue was added in version 3.8. Then came stream queues in version 3.9, and then lastly, the MQTT quality of service 0 queue in version 3.12. Now, as we talk about these different queue types, there are certain keywords we're going to be using repeatedly. So let's just go over them quickly. Queue durability. Now, you could create a queue as either durable or non-durable. Now, durable queues would survive a node restarts, and non-durable queues would not survive a node restarts. Now, you could declare certain queue types, just one actually, as exclusive. Now, an exclusive queue can only be accessed by one connection, usually the declaring connection. And you could also have auto-delete queues. Now, auto-delete queues are automatically deleted once the last subscribing clients, consuming client disconnects. Now, messages published to a queue could also either be persistent or transient. Now, persistent messages would survive a node restarts, but transient messages would not. Now, let's start with classic queues. Like I said, classic queue was the only queue type in RabbitMQ when it first launched in 2007. Classic queues are non-replicated, and so what this means is you don't really get data redundancy or data safety with classic queues. But that's not all. When RabbitMQ launched in 2007, disk access was significantly slower. So initially, classic queues were designed to just buffer the messages in memory just to avoid disk write. But as time goes on, disk storage technology advanced, and so the need to avoid disk writes also declined. And consequently, in version 3.6 of RabbitMQ introduced the notion of lazy queues. Now, a lazy queue is not really a new queue type. It is just a feature that you can turn on and off on classic queues. So in the lazy mode, classic queues would write their data to disk automatically just to conserve memory. But you should know that the lazy mode no longer exists in RabbitMQ from version 3.12 and above. And this is because the default behavior of classic queues right now is just to write data to disk, which kind of makes the lazy feature irrelevant. Then came version 3.10 of classic queues, where the classic queue rethinking process started. Classic queue version 2 was introduced in RabbitMQ 3.10 and then improved in every minor version, culminating in 4.0, where classic queue version 1 was removed. So in RabbitMQ version 4.0 and above, you no longer have our classic queues version 1. I just thought to also add this. Long before other queue types were introduced in RabbitMQ, the de facto way of getting high availability has been with classic mirrored queues. But we discourage the use of classic mirrored queues in the strongest terms because they have very known issues. And even more importantly, they've been removed in version 4.0 of RabbitMQ as well. Classic queue features. Now, you could declare a classic queue as durable or non-durable. We've already covered what a durable queue is, non-durable queue is. Now, you could also create an exclusive classic queue or an auto-delete classic queue. Now, exclusive auto-delete queues are just collectively called temporary queues. You could also set a message and queue TTL on classic queues. Now, a message TTL is just a configuration for specifying how long you want a message to survive in the queue. And then the queue TTL is basically, it's kind of the same, but it's just how long you want the queue itself to survive on the broker. Now you could set a queue length limit on the queue as well. It's just how long do you want the queue, so the queue is allowed to grow, or how many messages the queue is allowed to sustain at the time. You could also work with priority queues, with classic queues. And how this works is you declare the queue as a priority queue, you set a priority number on the queue, and then you publish messages to the queue with a priority number as well, but the number has to be equal to or below the priority number you set on the queue. Now, messages with higher priorities will be consumed first. You can also work with dead lettering classic queues. It's just basically a configuration for specifying where you want messages that have been discarded to be routed. So this is especially useful if you don't want to unintentionally lose messages, then you can declare a dead letter queue. Now, some good to know or good practices for classic queues. Because classic queues are non-replicated, they're ideal for less critical use cases where you do not care very much about data safety or high availability. Now, I need you to pay attention at this point because this is a problem that I've seen with our customers over and over again personally. Now, if you want your queue and the messages to survive on node restarts, then declare the classic queue as durable and persist the messages with delivery mode set to persistent. So you need a durable queue and persistent messages if you want the queue and its content to survive on node restarts. And I say this because I've personally seen situations where a customer declares a durable queue, but they're sending transient messages to the queue. When they restart their nodes and the messages are gone, they reach out asking, where did my messages go to? The messages disappeared because you're working with transient messages, and transient messages would disappear regardless of whether you're publishing them to durable or non-durable queues. Moving on, always use classic queue version 2 if you're on the RabbitMQ version that's below 4.0, but you don't really have to worry about that if you're on a new RabbitMQ version 4.0 and above, because classic queue version 2 is the default and only available option. Now, if you're working with priority queues, we recommend setting the priority level to between 1 and 5. That's because higher priority numbers have more CPU and memory footprints. Now, again, let me reiterate, do not use classic mirrored queues. If you're looking for data safety and high availability, there are other queue types to consider. We're going to look at them soon. Yeah, so before I move on to the next queue type, I'm happy to answer questions if you have any.
Yeah, some questions about classic queues in RabbitMQ. Yeah, we did have a question about some documentation, but we'll be sharing this after the session, and we can chat directly as well to fine tune the documentation that you're looking for. Well, we have some questions we can check into. One question that we get a lot is classic queuing mirroring going away? And that's always a big piece.
Yeah, good question. In fact, it's gone already in version 4.0, and it has been deprecated for some time from RabbitMQ 3.13. So if you're working with mirrored queues in the versions below 4.0 and you want to upgrade, I think you should migrate to, let's say, Quorum queues or a different queue type before upgrading, because you would no longer be able to use classic mirrored queues in 4.0 and above.
Very nice. We have a question about priority queues and how that works with classic queues.
Yeah, you declare a queue with a priority number. Let's say you set it to 3, and then so you publish messages with a priority number as well, but the number has to be equal to the priority number you set on the queue or below. So equal or below. So if you're working with 3 on the queue, it has to be from 1 to 3. So messages with higher priority numbers in the queue would always be consumed first, and lower priority numbers would always be in the queue. Yeah. I hope that answers your question.
Great. Yeah, and with classic queues, there can be, with priority messages are always over lower priority messages, so can lead to a message buildup where lower priority messages are not ever consumed.
Yeah, right.
Yeah, let's read through the comments here. We got some more questions coming in. And then I think we'll maybe dive into a migration about the possibilities when we talk about the next section from classic to Quorum. I think that'll be good to talk about after we dive into the next queue type.
Yes. Yeah, so I can just move on to Quorum queues then. Yeah, so Quorum queues, like I said, they were introduced in version 3.8 of RabbitMQ, and unlike classic queues, Quorum queues are replicated. And what this means is, if you're working with a Quorum queue in a multi-node environment, depending on the number of nodes you have in your cluster and the replication factor you set, each Quorum queue you declare would have replicas on some or all the nodes in your cluster. Now, the replication factor is just how you define the number of replicas you want for each Quorum queue you declare. Now, so for example, if you're working with a 3 nodes cluster and you set your replication factor to 3, now 3 copies of your Quorum queue would be created in the cluster, 1 on each node, with one of the replicas being the leader and the rest of the replicas are the followers. Now, all reads and writes would go through the leader, and the leader is responsible for replicating these changes to the followers. Now, if the leader fails, a new leader is automatically elected. Now, under the hood, QuorumQ uses the Raft consensus algorithm for its data replication and leader election as well. Now, QuorumQ features, like I said, QuorumQs are replicated, they are durable as well. So you can't have a non-durable QuorumQ, and messages published to QuorumQ are always persistent as well. So you can't really work with transient messages with QuorumQ. So there's a pattern here with QuorumQs, with drifting away from the transient entities we've seen with classic queues. With quorum queues, there's still some classic queue features that you could work with in quorum queues as well. For example, you could set a queue and message TTL. You could also work with queue length limit. You could also work with message priorities. However, some of these features behave slightly different than they do in classic queues. Now, one feature that is unique to quorum queue is poison message handling. Now, a poison message is simply just a message that tends to get requeued repeatedly by a consumer, probably because it is corrupt and the consumer can't process it. Now, the problem with poison messages is if you do not handle that scenario well, your message could just, you're going to have an infinite requeue loop, and your queue will just keep growing unnecessarily. Good news is quorum queues allow you to set a delivery limit, which is basically just a configuration for the number of times a message can be requeued. So once that limit is exceeded, the message will be discarded. But of course, like classic queues, if you do not want to lose your messages, you could set up a dead letter queue where these discarded messages are routed to. Yeah, some good practices. Because quorum queues are replicated, they're durable, they're ideal for very critical use cases where you're very concerned about data safety and you also want high availability as well. Now, important to note is a quorum queue would only be operational, functional if majority of the nodes or replicas are online. So if you're working with a 3 nodes cluster for a quorum queue to be operational, at least 2 of the nodes have to be online. If you're working with a 5 nodes cluster, at least 3 of the nodes have to be online. And I'll explain to you why this we have this majority requirement. Like I said earlier, quorum queue uses the Raft consensus algorithm, right? Now, how Raft works is for a
Looks like Nyior froze a little bit. We're going to wait for him to reconnect. Oh, you're on mute. Yeah.
Yeah, I just said that. Oh, this happens every once in a while.
oh, yeah. Okay. Can you hear me now?
Yep.
Yeah, I
all
can hear you. Go ahead.
Yeah, okay, cool. So I was just saying the majority of nodes is required because how Raft works is for an operation to be considered successful, majority of the nodes or replicas have to agree on the operation first. So for example, if a producer writes a message to a queue to the leader, majority of nodes have to say, yes, we've seen this change, we've accepted it for that operation to be considered successful. It's why you always need a majority of the nodes online. Now, because the majority of the nodes is required to be online, we recommend working with at least a 3 nodes cluster if you're working with quorum queues. And this is because if you think about it, below 3, your other options are a 2 nodes cluster or a 1 node cluster, right? So with a 2 nodes cluster, the majority is usually all the nodes in the cluster. What this means is all the nodes have to be online all the time. So there's really no fault tolerance if you think about it. Moving on, we recommend setting a delivery limit just to be able to handle poison messages, and work with that dead lettering as well, just so you don't unintentionally lose messages that have been discarded. Now, you should also know that queue and message TTL with Quorum queues generally result in some memory overhead. So use these features when you just absolutely need to. And yeah, that's it for Quorum queues as well. I can take questions at this point if we have any.
Yeah, questions about Quorum queues. We did have one from talking about classic queues, talking about some ways to migrate from classic to Quorum.
Yeah, good question. Now, just to get it out of the way, just to migrate from classic to Quorum queues, there isn't really just a one-click solution where you can just click a button and you migrate. But there are a couple of options, a couple of ways to approach this. So you can maybe, if you have your classic Nyior queues already, you could create a new Quorum queue, move your publishers to the new Quorum queue. Now, consume all the messages in your classic Nyior queues, then move your consumers to the Quorum queue as well. So let me just say you create a new Quorum queue first to the new queue you've created, then eventually move your consumers as well to the new queue.
Thanks.
Just
Yeah, no, we're just going to reconnect, I believe. This happens a little bit.
yes. So I was saying you could use shovels as well. Shovels as well. Just shovel your messages from the classic Nyior queues to your new Quorum queue. You can use federation as well. Just federate messages from your old cluster to the new cluster. Yeah, these are just the options that you can go with. But I'm sure there should be other ways of going about this.
Yeah, a lot of ways to accomplish that. We had our next question. We have, is it okay to create Quorum queues on a single node cluster? And like if they want to take advantage of poison message handling.
Yeah, I guess you can do that. But like the primary use case for Quorum queue is when you really want data safety, just data redundancy and high availability as well. This is what they were built for originally. But of course, you can work with it on a single node cluster as well.
Great. And yeah, let's see. I think we have. Yeah, we talked about migration and what happens to single node. Then I guess we can maybe highlight kind of like a newer feature, the priority queues. Now that's how does it work compared to classic queues in Quorum?
Yeah, good question. I just left that out. Good that you're pointing this out. So with classic queues, the priority messages are always delivered first. So the lower priority messages would always be in the queue. But with Quorum queues, the ratio is 2:1. So priority messages are sent, but low priority messages are always sent to the consumer, just in a ratio of 2:1. Yeah. So it's just to sort of put it simply, just give low priority messages a chance as well of being processed, instead of as opposed to just sending high priority messages only to the consumers.
Okay. Great.
If we don't have more questions on Quorum queues, I guess we can just talk about stream queues as well.
Sounds good.
Yeah, great. So stream queues. Yeah, so stream queues were introduced in version 3.9 of RabbitMQ. Like Quorum queues, these queues, stream queues, are also durable, replicated. Messages published to a stream queue are always persistent as well. And under the hood, stream queues also use the raft consensus algorithm. You're going to always have replicas, with one of the replicas being the leader, and then the rest are the followers. Now, at this point, you're probably wondering, you probably have connected the dots. Stream queues sound a lot like Quorum queues, but they're different in a couple of ways from Quorum queues. One is stream queues are immutable, so they possess a non-destructive consumer semantics. And I'll explain this more simply. So with classic and Quorum queues, a consumer reads a message, sends an acknowledgement, and the message is removed from the queue. With stream queues, messages are never deleted. Well, that's not entirely true, because you can do that with retention. We'll talk about that. But the consumer behavior is not to delete messages from a queue once the message has been consumed with stream queues. And that's because under the hood, streams use an append-only log that you can just add messages to the log, but you can't really just delete messages. Now, because a message is immutable, it's not deleted from the queue. With stream queues, consumers could benefit from repeatable reads. So one consumer could read the same message over and over again, and a consumer could go back in time as well to read an old message, time travel. But here's the thing. Since stream queues are immutable, in theory, they can grow infinitely until your disk space runs out. And you probably wouldn't wonder, right? So streams have a retention feature where you can specify, where you can just configure a way to get rid of messages that you no longer need. And there are two strategies, retention strategies that you could go with. You can either go with a size-based retention strategy, and in this approach, you get rid of old messages once your stream queue reaches a certain size or certain length. There is the time-based retention strategy as well, where you get rid of messages that have been in the queue for, let's say, a certain amount of time. Yeah, some good to know about stream queues. They're good for large fanouts, and that's because since messages are immutable, or a message is not deleted once read, you could have multiple consumers reading the same message. You can do this with classic and Quorum queues too, but it's a bit harder to implement. And Quorum queues do well with large backlog of messages as well. And like I said, you can benefit from repeatable reads with stream queues as well. Now, generally speaking, a stream queue is good if you're looking for like Kafka-like features in your RabbitMQ environment. Lastly, so there are two ways you could work with streams in RabbitMQ. You could work with it via the AMQP protocol. Now, the advantage of that is if you're introducing streams to your architecture, then you don't really have to make a lot of changes. If you're already working with AMQP to consume messages from classic and Quorum queues, then you don't really have to make a lot of changes. But the downside is the performance with AMQP and stream queues in RabbitMQ isn't very great. The second alternative is to work with the binary stream protocol. Now, the good side of this is the performance is great. I think it has been benchmarked at around 1 million messages per second. So the performance is really great. But the downside is if you're already working with MQP and you want to introduce streams into your architecture, then you have to make a lot of changes to your existing code base. Yes, I can take questions on streams as well, if we have any.
Nice. We have a question comparing it to Kafka. As about a Kafka topic, how that relates to streams in RabbitMQ.
Yes, good question. They're very similar in a lot of ways. Kafka topics are also immutable, and streams are also immutable. And I think Kafka topics have these partitions also, and with stream queues you have superstrings as well. So yeah, they're very similar in these ways.
Nice. And then our next question we have about combining retention policy. Can you combine size and age retention policies?
Yeah, you can combine both of them. Now I have to look at this again. I don't know which one takes priority when you combine both, but I know it's possible to combine both size and time-based retention strategies. One takes priority. I don't know. I don't want to say what I'm not sure of, but yeah, it's possible to combine both strategies.
And then we have one about comparing to Kafka on performance and partitioning. That one, it's hard for us to dive into because we'd have to benchmark per use case. But do you have to add on what performance is like?
Yeah, I know for sure that you get a throughput of around 1 million messages per second with RabbitMQ streams. Yeah, so I don't know what it's like in Kafka, so I can't speak to that. Yeah.
Very good. And then we have a question: Are stream queues as safe as Quorum queues?
They're safe to an extent, but Quorum queues are built primarily for data safety. So you have yeah, you get more safety with Quorum queues than you do with stream queues, because in stream queues you don't even have publisher confirms, but what you do with Quorum queues. So Quorum queues are safer.
Great. Don't see questions coming in the comment section at the moment.
Yeah. Yeah, there are no new questions. So if you don't have more questions, I can just move on to the last queue type as well. And this is going to be real quick. Now, this queue type, like I said, was introduced in RabbitMQ version 3.12. And I'll just give you a bit of a background first before we just talk about the queue itself. So RabbitMQ, in addition to AMQP, supports MQTT as well and other protocols. Now, MQTT is a very lightweight protocol that was designed to just primarily be used in areas with unreliable networks and low bandwidth networks as well. So think of IoT devices that are being used in areas like this. Now, this queue was primarily designed for IoT scenarios, just to work with the MQTT scenarios, just to work with the MQTT protocol. So before this queue type, and in fact, this is the current behavior with MQTT. And the MQTT protocol uses the plastic queue by default under the hood, but you can configure it to work with Quorum or stream queues as well. Now, here's the thing about classic Quorum and stream queues. They write data to disk, and this could have a negative effect on throughput and latency. Now, some MQTT scenarios just require just broadcasting messages as they come to all the online subscribers without the overhead of writing data to disk first. And this is why this queue type was created. So the MQTT queue or S0 queue does not really write data to disk. As soon as a message comes in, it broadcasts it to all the online subscribers. Yeah, so you probably have figured this out. Messages are very, very ephemeral when working with the MQTT queue. So only use this queue type when you do not care about data safety at all. Yeah, And that's it for this queue type.
Yeah, pretty new queue type and not very commonly used as well.
Yeah. But yeah, just to add, if your use cases, if you're looking for really large fan outs, you just want to broadcast the message to a lot of subscribers, and you don't really care about data safety, then this queue type is also good for your use case.
And I guess question about this queue type is flexibility of it. Are you able to add policies to the queue?
No, so it's not a very flexible queue. What you see is what you get. You can really customize it. Yeah, but one thing, to be able to work with this queue type, you have to enable a certain feature flag. Otherwise, it wouldn't work. But yeah, you can add policies. You can just customize it with policies.
Nice. I'm reading some questions here. I think we may need more information on that question that we have in regards to exchange publishing and consuming. Yeah, if you want to write that question in,
Yeah, maybe I think I have like understand a bit of what the person is trying to ask. So I think this presentation was mostly about queues, so we didn't really touch on the other aspects of the MQP protocol. You have to publish messages to an exchange first. Well, it depends on the MQP version you're working with. But yeah, here we're talking about 0.9.1. You have to publish messages to an exchange first, and the messages are routed from the exchange to a queue. So you can't really publish messages directly to a queue.
we have a question about overall use case. Is Quorum queues best fit compared to other queues?
Yeah, I like to think of Quorum queues as having a little bit of everything. So yeah, if you're looking for data safety, high availability, Quorum queues are your best bets. They have decent performance as well. Yeah, but if your use case is very, very basic, then it's best if you just start with classic queues. I think that's what they're best for, just very basic use cases. Yeah, but Quorum queues are great for most of the use cases you could think of. If we don't have more questions, right? Yeah.
Yeah,
All right.
Great.
Yes. I'm happy to answer your question, Cynthia. I hope I didn't get your name wrong. Someone said looking forward to RabbitMQ4.
Depends on how backwards compatible to what version, but there is ways to upgrade from early versions to 4.0, but there are some. Yeah, I don't know if you want to dive into the automatic conversion between, like, if you're Classic Q version 1 to 2, or
Yeah, and I just noticed there was a question about this as well. Someone said, something about upgrading to Classic Q version. Yeah, will the Classic Qs automatically be updated to version 2? And yes, if you're on Classic Q or version 1 and you upgrade to 4.0, under the hood, RabbitMQ would just convert your queue to Classic Q version 2. So it's not something you have to do yourself or worry about. So, creation of queues is. I'm just answering the last question here from voice and strings. So creation of queues is important, right? So if you create it from the publishing side already and you try to create it from the consuming side, it won't be created twice because the queue already exists. So yeah, it's not super important whether if you're creating from the publishing side or the consuming side. Yeah. I think we're running out of time, and we still want to talk to you guys about LavinMQ because we think it's interesting. So I'll hand it over to my colleague Dustin, who would introduce you to LavinMQ in general. The stage is yours, Dustin.
Thanks, Nyior. Yeah, we have like another segment for you. At CloudAMQP, we host 2 message brokers, RabbitMQ and LavinMQ. So we have, we're going to dive into a little bit of queue types on LavinMQ as well. Yeah, so LavinMQ is our in-house developed message broker. We've been hosting for about 12 years or so, started, I believe, in 2012. So we have a lot of experience hosting message brokers from very popular message brokers, RabbitMQ. We've hosted Kafka as well. So we decided to take what we like and also leave out what we didn't and make our own broker completely from scratch. This is not a fork of an existing broker. This is completely created from the ground up. Yeah, so in LavinMQ, there are 2 main queue types. So contrast with RabbitMQ with a lot more queue types. With Lavin, it aims to be simplicity is key. So we have a standard message queue and also a stream queue. A little history of LavinMQ. It's relatively recent on its release. So just last year, version 1 was available, and then streams introduced a little bit later that year. Clustering is now available this year, just a little bit ago in version 2.0. And the feature we have, it's a young message broker, so MQTT will be available. And then, yeah, so the broker itself takes a lot of consideration. So it's a relatively young project. And LavinMQ aims to be very efficient. It's simple and performant. That is owed to being written in Crystal, which is, I like to say, the syntax is very much like Ruby, and it compiles down to C, and it's very speedy. So high performance. In benchmark testing, we've clocked it at 1 million messages a second. That's about 16 kilobytes per message. So pretty high throughput and very low resource usage. So we took a lot that we saw about other message brokers and how resource intense they are, and we researched a lot, and we made a broker that's a lot more efficient, utilizing the operating system caching and also ability to utilize disk performance. So for the main queue type with LavinMQ, they're, again, very similar to RabbitMQ. The main queue type uses the 09.1 protocol that is available strictly with LavinMQ. There's so that's a major piece as well with queue type. Again, very similar to RabbitMQ, QuorumQ, and Classic Q. All the features here about durability, exclusive. One piece that is about passive. That is a way for the broker, for the application, to check if a queue exists. So that's a pretty handy piece if you're just looking to check, and it doesn't use a lot of resources. So it'll return with declare OK, and then if the queue doesn't exist, then it will raise an error. And then again, has a lot of same features as RabbitMQ, also with the 09.1 protocol specifications. So there's message priority, there's dead lettering, and time to live for both the message and the queue itself, and also length limit as well. So still able to make your broker safe and not get overwhelmed while it's in use. Let's see, I think, yes, some good things to know about the main queue type for LavinMQ. Most important piece is 09.1. It's a great implementation of the protocol. Pausing a queue is a feature which is pretty unique, very unique to LavinMQ. You can pause directly from the user interface. So if you want to pause publishing, that's from the broker to consumers. And then also it's general purpose queue. So like imagine the use when compared to Rabbit of your Quorum or Classic Q. That's going to, the standard queue type is going to be your one-stop shop for that. And here's just showing the pause queue capability within the user interface here. It's just when you select the queue, it's just down on the page, and you're able to pause publishing to consumers. If you need to reconfigure something or just add some additional layers of safety there. So I need to actually add in, I'll pause here for if there's questions about LavinMQ standard queue type. Oh yeah.
There's one question already from the audience. What protocols is LavinMQ compatible with?
Yeah, that's a great question, and very important to consider when you're choosing between message brokers. LavinMQ is implementation of the 09.1 advanced messaging queuing protocol. And at the moment, that is the only protocol it supports. There is in the works for MQTT, and don't have a date for that, but expect that in later release. So, and to contrast, it does not use MQP 1.0 like where RabbitMQ uses, but the 09 protocol is very efficient and is just a great use case for it.
Yeah, it's this is this question. I think the audience, no one has asked, but the audience might just be curious. You said LavinMQ also supports 0.9.1, right? So is it possible to just, does LavinMQ require some special clients, or can you just work with the clients you've been using with RabbitMQ?
That's a great question. A lot of clients are created with RabbitMQ in mind, but it is just implementing the 0.9.1 protocol. So you can actually use any client that utilizes that protocol. So you're able to use all the great support that with the RabbitMQ community that has 0.9.1 clients. So you're able to work with pretty much any language you like in those clients that utilize that protocol.
Great, thanks.
I can move on to the next queue type for LavinMQ. Add your questions into the comment section if you think of some more. The stream queue type shares a lot of similarities with RabbitMQ streams. I'll just point out some of the main differences. It is same as immutable. There's retention. There's all kinds of regular policies that are shared, and also with offsets. But the main difference is that it's still an implementation of the 0.9.1 protocol. It is doesn't use a specific stream protocol, but think of it more as an extension to regular queues than it's like a more separate queue type. Still good for large fanouts, but like with other stream-based, it is more resource intensive. So something to consider for use cases. Yeah, large fanouts, and then can only be durable as well. So you cannot mark it as temporary when on declaration. And then for consuming, they cannot use with auto acknowledgements. And there are some additional arguments as well. So in addition to the regular queue type, there's max length, max size, and max age, very similar to RabbitMQ streams. So still able to customize those retention and auto expire policies. I think, yes, that's, now here I can pause for questions about LavinMQ streams.
Do we maybe know how RabbitMQ streams compares to LavinMQ streams in terms of performance, or maybe not yet?
Oh, performance is a good comparison. LavinMQ utilizes 0.9.1 protocol, so there's as opposed to a specific stream protocol. So there are some performance pieces that makes it more resource intensive on LavinMQ side. Still able to handle high throughput as well, but streams, it's all about use case as well. So depending on your desired throughput or your message sizes to the log. So it's, yeah, it basically say to do some testing with them to compare. Yeah, so we have a little bit more time left.
Yeah.
I can go over kind of new feature within LavinMQ
Yeah.
really briefly. So LavinMQ now has clustering available, utilizing etcd, same as Kubernetes. It's available in version 2. Utilizes heartbeats that etc relies on from the leader to the followers. Helps keep track of everything there. Let's see. Yes. So version 2.0, very recently released. You can find that available on the LavinMQ GitHub or through CloudAMQP. Some things to keep in mind. It's like with other clustering as well, performances is not where clustering kind of is its strong suit. It's more for data safety. So with this, you're still able to replicate and have leader elections. etcd utilizes Raft consensus algorithm. So there's leader elections. There's a term that it has to go through when one node goes down, and it finds a new leader. Yeah, so there's so happy to show that we have clustering available for LavinMQ and for the main queue type and streams as well. So there's can be from both the queue types for LavinMQ. I think, yes, I have heard overview there.
Thank you, Dustin and Nyior, for this session. Very informative. If you feel like you didn't have the chance to ask your questions, feel free to send us an email at contact@84codes.com or connect with us on LinkedIn and Twitter. Again, thank you for listening, and stay tuned for upcoming live streams with CloudAMQP. Have a nice day.
Thanks, everyone.